All right, so let's go ahead and do an example. So let's start out with a basic example. So let's suppose that I had the function y equals, let's say, sine of 3x. Okay, and if you guys remember, when you have a number inside with x, it lies to you. So instead of making the period longer, it makes it shorter. Okay, so instead of taking 2 pi and multiplying by 3, that's not how you find the period here, because anything inside with x does the opposite. And so the normal period of a trig graph, because if you go all the way around the unit circle, how many radians is that? 2 pi radians. So when you go all the way around the unit circle, so all the way around, ooh, wow, that was so that's 2 pi. So the normal period of any trig graph is 2 pi. So in this case, it would be 2 pi divided by 3. So that would be the period of this graph. Okay, does that make any sense? So I don't know how far you guys have gotten into Khan Academy, but have you guys seen this formula yet? And I don't even know if Khan gets this deep into it, to be honest, but all right, so this is the kind of the basic form of any trig function. You could replace the sine with cosine or cosecant or whatever. It just changes the shape of the graph. But each of these has a meaning. So this first one up here, that would be amplitude. Okay, so the A is the amplitude. This one right here is the horizontal shift.
The C?
Yep. And just so you know, horizontal shift has a name. We call that, we don't usually call it horizontal shift. We usually call it phase shift. Okay. And the reason it's called phase shift is because in science, when you shift like an audio wave or a light wave, you're changing its phase. And so that's where that comes from. And then this is called, or this is the vertical shift. So how far up and down does it go? Let's go ahead and tackle a more complicated case then. So let's suppose that I had an equation that looks like this. So y equals 3 cosine of 1/2 x minus 4 pi plus 2. Okay, suppose that was the equation I had. Now, the first mistake that people are always going to make when they have this is they're going to look at that and they're going to just start working with the numbers as they see them, and that is wrong. You never want to take an equation that looks like that and just start chomping away at it, because I don't know if you guys notice, but this part of the equation does not have the same format that I wrote earlier. So there's a number in front of x inside the parentheses, and you don't want that, because you want to break this apart so that you have x minus a number. That way you know the phase shift. So you have to pull that 1/2 out. So the very first step that you have to do is you have to pull out a half. And 1/2 times what would give you 4 pi? So 8 pi. Okay, so the first thing I have to do is pull this number in front of x out. Otherwise, I'm going to have an inaccurate phase shift, because this number right here needs to be outside the parentheses before I start working with it. Okay, so really the equation that I have is 3 cosine of 1/2 x minus 8 pi plus 2. And now it's okay to start looking at those numbers and saying, okay, what does this mean about this equation? So let's just list out what the different features of this graph would be. So amplitude, period, phase shift, which I'll just call phase, and vertical shift. Okay, so amplitude is there. Period, we're going to look at this number right here, but we don't just take that number, we have to remind ourselves that this lies to us. So it's not half of the normal period. It's really whatever the normal period would be, which is 2 pi for cosine, divided by 1/2. So it undoes things inside the function, do the reverse or the opposite of what you think they do. So instead of multiplying the period by 1/2, it actually divides the period by 1/2. And if you take 2 pi and divide it by 1/2, well, you can do copy dot flip. So 2 pi and then times 2 over 1. So then the period here is 4 pi over 1, or just 4 pi. Period always requires a calculation. You can't just take the numbers from the equation and find the period. You have to do a calculation, because you have to remember that the normal period of sine, cosine, cosecant, and secant is 2 pi. Tangent is different because it depends on both sine and cosine. Then phase shift, if we go look at the phase shift, that minus, remember things inside the function lie to you. So instead of moving you to the left, it moves to the right. So it would go right, and it's very important to be specific, right 8 pi, because it will look very different if you go left 8 pi, or it could look different. Okay, so the graph shifted right 8 pi, and then the vertical shift is at the end. Sometimes, just so you guys are aware, sometimes this number is not written here, it's actually written up here. So it could be written up here instead. And that's actually very common in math because we don't like things trailing the trig function. So a lot of mathematicians write it this way. So be aware of that. I can't remember which way your book does it, and I don't know, I can't remember which way Khan Academy does it because I'm so used to seeing it so many different ways. But which direction does it move? What number or what sign is right here? Even though it's not shown there, it's a positive, so it moves up 2. Things outside the function do exactly what they look like they do. Okay, so starting with this function, that was what we started with. First step was to reorganize. Okay, and then we can go through and identify all of the properties or features of the graph. And these are all the primary features of the graph. And we're gonna graph it now. Now I need to explain this graph paper I'm looking at right now because this is the traditional trig graph paper, and it looks a lot different than coordinate grid paper, but it's not different. Okay, so when I look at this graph paper, this right here is 1. Okay, this is not 1. This is pi over 2. This is pi, 3 pi over 2, 2 pi. So it's designed to do rotating around the unit circle, laid out flat. Okay, and the reason that it's kind of stretched this way is because to make the graph equal, it turns out that 1 is about right here. So that's about 1 right there. Okay, and so if you look, that distance and that distance are about the same. Okay, so this is what's called trig graph paper, trigonometric graph paper. And we use this anytime we are graphing trig functions because it's way easier than using regular graph paper. And each of these marks is lined up exactly where you would find the key angles on trig graph paper or on the unit circle. Okay, so it would be like 0, 30, 45, 60, 90, 120, 150, or whoops, 120, 135, 150, 180, and then 210, 225, 240, 270, et cetera, et cetera, et cetera. So as you go around the unit circle, it's just they're spaced the same way that those angles are as you go around the unit circle. So to graph my graph, here's where we go. So let me first of all remind you what our rewritten graph looked like. It was y equals 2 plus 3 cosine of 1/2 times x minus 8 pi. And so that's how I rewrote the graph, or rewrote the equation. And it is a habit for me to always put this number out in front so that it's not trailing. That's just a mathematical convention, but it's not required. So I'm going to go ahead and erase the writing I put on the graph over here. Okay, and we're gonna start graphing this. Now the first thing, do you guys remember what the period was? 4 pi. Okay, that means that every 4 pi, this graph is going to repeat itself. Okay, look at our phase shift. What is the phase shift?
8 pi.
8 pi. Now, if the graph repeats itself every 4 pi, does it even matter that I've shifted it 8 pi? Because if I do 4 pi, so if I go 4 pi, and then another 4 pi, well, there's my 8 pi. If I shift that whole graph over 8 pi, it's just going to line right up where it was. So it turns out in this particular case, the phase shift has no impact on the graph because the period is a multiple of the phase shift. Okay, so or the phase shift is a multiple of the period. So phase shift is a multiple of the period. So there will be no visual difference. Okay, but we'll do one where it does make a difference as well. So that means that really I can just start graphing right here. I don't need to phase shift. If I did phase shift, I'd have to phase shift way out there, right? But in this case, it's not necessary. So then what I'm going to do is take that period of 4 pi, and it turns out that 4 pi, well, this is half pi, 3 pi over 2, 2 pi. 4 pi ends up being right here. There's 4 pi. That means that my period happens from here to here. And in any trig, or any sine or cosine graph, or cosecant or secant, how many quadrants fall onto the unit circle? How many quadrants are there? There are 4 quadrants, okay? And because of that, the graph is actually going to have 4 parts. So I'm going to take this and I'm going to divide it up into the 4 quadrants by just cutting it in half first, then cutting each of those in half. So this would be like quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Oops, that's not a 4. There, 4. Okay, so that's like, those correspond to the 4 quadrants on the unit circle. And the next step then is, now that I've divided the period up into 4 parts, I know that the shape of cosine, if I go look at the graph of cosine, or if I just think about the unit circle, on the unit circle, and my circle drawing skills are horrible today, I'm still getting used to this tablet because it has such a slick surface. I really need to tape a piece of paper to it. So cosine depends on what variable? Depends on x. In this case, x is 1, y is 0. So cosines at 0, cosine starts at a value of 1, which means I'll come up here, and normally it would start at 1. But the difference in this problem is that this graph has an amplitude of 3. So to help myself make good decisions here, before I start graphing this, I'm actually going to look at these two numbers. This number tells me where the midline of the graph is because it's moved the whole graph up 2. So I'm going to go up 2, 1, 2. So the midline of the graph then will be right here. So you guys have already dealt with midline and amplitude so far, I believe. So then from here then, I need to go, the amplitude is 3. And that means I go up 3 and down 3. So 1, 2, 3. And that means that the low will be down here. Unfortunately, I can't draw off the screen on this one. And the high will be up above. I'll just put it up here, even though it's not quite right, just so you guys know it's up here someplace.
Mm-hmm.
Okay. And so I'll go above 3 and below 3 as I'm going back and forth. And that's because normally cosine would go from 1 to -1, 1 to -1 as it goes around the unit circle. In this case, though, it's multiplied by 3. But notice I marked the center line because everything's moved up by 2. So there's the center line. Amplitude up 3, amplitude down 3. Now I can start figuring out where the points are. Cosine starts at its high point, so up here. Then as I go around, now cosine, the x value is 0 right there. So now I'm at 0, 1. Ooh, I need to put a piece of paper in here. And then, so that means by the time I get to the end of quadrant 1, I will be back at the center line. Not at 0, at the center line of the graph. And that's important. Everything is shifted up by 2 units. Then, as I keep rotating around through quadrant 2, I'll get to -1, 0. So cosine depends on x. That means it's going to be down at its bottom point. So I go down 3 units at the end of quadrant 2. Then in quadrant 3, I rotate around. Now cosine is back at 0 because x is 0. So I go back to the midline. And then eventually I find my way back to the high point. And that will be right here. Okay, and so the shape of this single period that I just graphed will look like that. Okay, so that would be one period of this cosine graph.
Okay.
So feel free to ask questions, stop me, raise a hand, etc., etc., etc.
So the point needs to be multiplied by 3, and then added by, and then plus that by 2. Is that what's happening?
Well, the way I always do it before I even begin, I don't know if you guys saw this, but I started by breaking the period up into 4 parts.
Mm-hmm.
So there are these, let me change colors real quick. So there are these like imaginary lines right here. End of quadrant 1, end of quadrant 2, end of quadrant 3, end of quadrant 4. Okay? So I've made these guidelines, these marks, but the important one here is right here. This midline right here is essential. This is the new midline for the graph because everything has moved up 2. Okay? Everything has moved up 2. And then once I know that everything's moved up 2, this number right here tells me that I'm going to go above and below that midline by that. That's the amplitude. So I'm going to go above by 3 units. Oops. And I'm going to go below by 3 units. And if you guys notice, there's like this grid I just built. There's like this box thing. And all that the function's going to do is bounce around inside this box. And that's what all these guidelines were that I drew. If you draw these guidelines either in your head, so if you draw those guidelines, it helps you, particularly if you're doing it on paper. Now, if you're doing it in Khan Academy, it's a little bit different. So do you guys want me to shift over there, or do you want to see another example first? So in this problem, they have graph y equals 5 sine of pi over 2. This right here is not our period. That's the coefficient that helps us find the period. Okay. And then this right here is our amplitude. And this is our vertical shift. There is no phase shift. Whoops. There is no phase shift in this one. And so let's start by doing the same thing I did before. So I'm going to go find the midline here. So 1, 2, 3, 4. It goes down 4. Oh, I thought I could draw on that. Can I not draw on that? Oh. 1, 2, 3, 4. So it won't let me draw on the graph. So down here is my midline. I have an amplitude of 5. So 1, 2, 3, 4, 5. So here's my, well, that stinks that I can't draw
Oh,
on the graph.
that's
And then 1, 2, 3, 4, 5. So there's my midline. This is the max. This is the min. The amplitude is in between. Are you guys okay with that so far? So that's the first thing I'm going to do. This right here helps me find the period, though I should factor it out technically. It should be written as 5 sine of pi over 2 times x, but it's not going to matter because that's the only thing there. So there is no phase shift, but to find the period, I take 2 pi because that's the normal period of sine or cosine, and this is a sine graph. I'm going to divide it because horizontal lies to you. The stuff inside the function lies to you. So instead of multiplying the period by pi over 2, it divides the period by pi over 2. Do a copy dot flip. Whoops, not 4, pi. There we go. Pi's will cancel. And so then the period is 4. So then, just like I did before, if I wanted to mark out the period, the period is 4, so I would start here. God, I hate that I can't draw on the graph. 1, 2, let's see, 1, 2, 3, 4. So there's the end of the period. If I divide it into 2 parts, and then 2 parts again. There are my 4 quadrants. That means that the graph will start here, but it will start on the midline. So it starts on the midline. And after 1 quadrant, sine goes, if you're going around the unit circle, after 1 quadrant, sine goes from 0 up to 1, its highest point. So then go to the max, but that happens after the first quadrant. So I'm going to drag this over, okay? And so then my period is 4, and I can check that now. If I go up, back down, and back to where I started, notice that that happens at 4. So my period is 4. My midline is at -4. My amplitude, 1, 2, 3, 4, 5. And so then I should be able to check that and got it right. The only difference between sine and cosine is that sine starts at 0 and cosine starts at 1. Or another way to think of it is sine starts on the midline, cosine starts on its
X.
maximum. Okay, so sine starts at the midline, cosine starts at the maximum. So like this is a cosine graph. Cosine starts at its highest point. So if I go through this, the amplitude, and this is going to mess with people a little bit, the amplitude here is not -2. The amplitude is 2, and then it's flipped. Okay, so but the amplitude is just 2. In this one, I have to do the same thing I did before. I take the period, I calculate that out by taking the normal period of the graph, which is 2 pi for cosine, and divide by 1/6. That's copy dot flip, so 2 pi times 6/1, which is 12 pi. Wow, that is a long one. Ouch. Okay. Woo! 12 pi. So then, now the one thing that's nice about this, though, is remember that there are 4 quadrants. So if I wanted to think this out, I could say 1 quadrant would be 12 pi divided by 4, which means 3 pi is 1 quadrant worth. Okay? I can actually graph this on this graph. Even though it only goes to 4 pi, I'll be able to figure it out because I know that 1 quadrant is only 3 pi. And then this has gone down 5. So the vertical shift is down 5. And notice I always either say the word down or I put an arrow. I never say just 5 or -5. Okay? So I always say a word or put an arrow so people know exactly what direction it goes. So the midline would be at -5. So there's the mid. It's got an amplitude of 2. So 1, 2, 3, 4. Or oops, 1, 2. There, I can do that. And so that's the max and the min. So it's going to fall between these lines. Okay. And then I know that the 1 quadrant worth, which this is actually 1 quadrant worth right here, as it climbs up to the top, that's 1 quadrant. But cosine starts at its highest point, except in this graph, it's been flipped. So it starts at its lowest point. So I'll go down here. There's its lowest point. It'll go back to the midline. Uh-oh. So I'm going to have to trade these points. Do you see that? This is always the midline. So I'm going to have to trade these points. So I'm going to move this point. So there's the midline. Cosine normally starts at its maximum, but because it's been flipped upside down, now it starts at its minimum. So it starts at its minimum, down 2 from the midline, goes back to the midline. Period is 12 pi. 1 quadrant would be 3 pi, so I need to move this over. There we go. So
Oof.
there is, and if you imagine, this graph is going to sweep and come back down out at 12 pi.
Mm-hmm.
Okay? 1/4 of that is 3 pi. That's why I did this calculation right here, because it don't have enough room to do the whole graph here. So I just did the this piece right here. And so then now that I have this, I can actually get the sine graph instantly. All I have to do is trade this point and this point, because sine starts at the midline and then goes to its maximum, which in this case is flipped. Cosine does the opposite. So if I take these 2 points and just exchange them, I go from sine to cosine. So notice cosine starts down here and then climbs up because it's been flipped upside down. Sine starts at the midline and then goes down to its minimum because it's been flipped upside down. But the only difference is in where these 2 anchor points are positioned. Where is the midline? Where is the minimum? Otherwise, sine and cosine look identical. If you took the graph off, like if you took these coordinates off, you could not tell the difference between sine and cosine in any case. So this is a kind of a normal sine graph. Okay? And to find the corresponding reciprocal function, remember that reciprocal functions just take whatever the current value is and you divide it, you take that, you take 1 divided by that number. And so let me switch colors here and I'll show you how I would do this. So what's 1 divided by 0? Undefined, which means, if you guys remember, we're going to have an asymptote here. So anywhere there's a 0 value, we get an asymptote.
Oh, it's gonna look kind of like tangent.
It's going to look freaky.
Tangent does look freaky.
Okay. So then what's 1 divided by 1? 1, which means that it will be right there. 1 divided by -1. And so I get these points. Turns out I have almost everything I need to graph cosecant, because cosecant, y equals cosecant of x, is the same as 1 over sine of x. And that's what I've just been calculating out. I've been taking all the sine values and taking 1 divided by them. So the graph of cosecant is actually, whoa, without all the squiggles. So nice smooth graphs, no squiggles. And it just follows those asymptotes. So it bends and follows those asymptotes. Okay, so the green is cosecant and the blue is, oh, that's not blue, sine of x. Okay. And that's how you would do it, like cosecant. You just take whatever, I just graph sine first, and then I mark off the asymptotes and mark off the maxes and mins. If you have an amplitude, it just stretches everything. Okay. It doesn't actually, these will still meet up if you have an amplitude, because it's actually multiplying the function, not just the reciprocal values. So the whole function gets multiplied. So if you had an amplitude of 3, this point would just go up to 3, just like this sine value would go up to 3. And so you calculate periods the same way. You calculate Amplitude's the same way. Vertical shift's the same way. Everything else is the same. Tangent is the more complicated one. Let me graph sine and cosine together real quick, because it turns out y equals tangent of x is really the same using the ratio identities as sine of x over cosine of x. So if I graph sine looks like this, sort of, okay? And cosine looks like this. Okay, and if we look carefully, anytime cosine is 0, we get an asymptote. Cosine is 0 right here. So then I'd have an asymptote right there. It's 0 right here, so I have an asymptote right here. It's 0 here, so I have an asymptote here. It's 0 here, so I have an asymptote here. Anytime these are equal, I get a 1. So if I look at the graphs here, let me change colors real quick. Right here, they're equal. Right here, they're equal. Those should have been equal, right? Like right there. I was a little sloppy, but they should have been equal there. So it turns out that at these places where the graphs cross, the graph will have a value of 1. Or actually, yeah, 1, because that's a negative divided by a negative, so 1. Negative divided by, or a positive divided by positive, so still 1. Negative divided by negative, so still 1. And then when they're opposites of each other, so like here and here, it'll be -1. Opposites, -1. Opposites, -1. And so then if you look at the points that I plotted that are not actually on the graphs, these ones and -1s, anytime sine is 0, so sine is 0, 0 divided by anything is 0, and so the graph will be 0, 0, 0, 0. And then if you look carefully, there's like this diagonal line going through all these places. And so the graph comes along the asymptote, turns, and then goes along the next asymptote. Comes along the asymptote, turns, goes along the next asymptote. That was just unacceptably messy. Okay, so, and it follows this pattern repeatedly. Midline would just move everything up. Amplitude for tangent, there is no such thing really as amplitude because this graph goes to infinity, but we can stretch it, okay, which is the equivalent of the amplitude. This point that's at 1, let's say I had, let me change to a different color yet again. Let's see. And let's say I had y equals, let's say 3 tangent of x, then all of these points that are now at 1 will be at 3. All of these here would be at -3. It just multiplies all the y values.